Leetcode question 648. Replace words. In English, we have a concept called root, which can be followed by some other word to form another longer word. Let's call this word successor. For example, when the root an is followed by the successor word other, we can form a new word another. Given a dictionary consisting of many roots and a sentence consisting of words separated by spaces, replace all the successors in the sentence with the root forming it. If a successor can be replaced by more than one root, replace it with the root that has the shortest length. Return the sentences after the replacement. Let's take a look at the example. The input dictionary contains cat, bat, and rat, and then this is the given sentences. So for the sentence, cattle is replaced by cat because cat is a root word exists in this dictionary. And then rattled was replaced by rat, and then battery was replaced by bat. So basically the whole idea is, okay, given a word in this input sentence, we're trying to see if there is a root word in the dictionary can match the prefix of this word in the sentence. If the root word in the dictionary matches, then we just replace the original word in the input sentence with the root word from the dictionary. So that's the logic for solving this one. So for the second example, we have the three root words in the dictionary. There are A, B, C, and then the sentences consist of 4 substrings. So those 4, if we split by the white spaces, so the first word starts with A, second word starts with A, third word starts with B, and then the last word starts with C. That's why the output is A, B, C, also separated by white space. So the idea for solving this problem is a variation of the Trie data structure. So we implement 2 methods. One is insert. This is the same as standard Trie implementation. We just insert the root word from the dictionary into the Trie. And then we are inserting character by character. And then the search method, we find the root word in the Trie that actually match the prefix of the input string. And then we return the root with the shortest length if there are multiple matches. So this is the idea for solving it. So let's code the Trie. So first, let's get a Trie node. So Trie is also a binary. Trie is also a tree data structure. So the simplest tree data structure we know, or we are more familiar with, is probably the binary tree. So in that case, binary tree, each node has left child and right child. So for the Trie node, we also want to track the children. Each Trie node can have multiple children. So that's why we are using a dictionary. So self.children equals the empty dictionary. And then we indicate, so for each Trie node, we indicate if it is the end of a complete word. So initially, we initialize that to false. So for this dictionary, so basically each key is the letter. So that, for example, it could be the letter A. And then the value is just the corresponding Trie node. So this is end indicate the end of a complete word. And then after that, let's code the Trie data structure. So for Trie, let's first initialize it. So we define the root node of this Trie. That is just empty Trie node. And then we define insert function. So we are insert a word into this Trie. So basically, the current node initially points to the root node. And then we are inserting one character at a time from this input word. So for the character in this input word, we check if this C not in current node.children. In that case, we create a key value pair here. So the key is just this character, and then the value is just a try node. And then we move on to the next node. So after we insert all the character from this word into the try, we set current.isEnd equals true. That means, okay, this node corresponds to the end of a complete word. So this is our insert method. Then let's implement the search method. So given a word, we are trying to search and find the corresponding root word from the dictionary. So currently, the current node still points to self.root. And then we also need to keep track of all the matching characters. So let's say when we are searching for cattle, we got match for C, got match for A, got the third match T, and then in the end we want to output the match CAT. So in that case, we need to have a variable to actually keep track of all the matched characters. So I'm using a list for that. So every time I have a matching character, and I just append that to the list. So for C in word, so for C in the input, for every character in the input word, if C not in current.children, so in this case, we don't have a match. So in that case, we just return the original word. Else, so current equals current.children C. That means, okay, when we find a match, we move on to the next word. Sorry, when we find a match, we move on to the next node. And then we add this character C to the result. And then if current, we also need to check, okay, after we find a match, if this current.isEnd is true, that means, okay, we reach the end of a complete word. So in that case, we can just directly return the results. So when we return the results, we want to return a string instead of a list. That's why we are returning the string. So basically, we are joining array elements from this result list into a string. And then let's say if we searched all the characters in this input word, and then still we do not find a match. In that case, we just return the word, the original input word. So after that, let's code the main function. Basically, let's initialize try equals try, and then let's insert for the word in dictionary. Let's insert into the try.insert word, and then let's do the search. Basically, for the search is for every word. Basically, for x in this sentence dot split, we call try.search this x, and then for this result, we want to concatenate them into a list. So in that case, let's use a result. And then in the end, we just return result. We just convert that to a string. So basically, all the words in this result is separated by the white space. Actually, we can write the last 4 lines in more Pythonic way. So in that case, I'm just going to use the list comprehension for that. So that is return white space dot join, and then this result is just the list, and then we call this try dot search x for x in sentence dot split. Okay, so this is the list comprehension. So we just replace the about 4 lines with this single line. Actually, for this one, I can write it in another way. So that is basically return white space dot join, and then here I'm using a map function. So basically call the map function try dot search, and then with the input that's sentence dot split. So this is our solution. Okay, so I made a typo here. Okay, this solution is accepted solution. So the runtime is about 70%, but it used the memory and only beats the 13%. So now let's take a look at this solution to see if we can further optimize it a little bit. So let's go over this solution one more time. So we define a try node, and then it has children, and then it has a variable indicates if the end of the complete word insert into the try, and then we do the standard implementation of insert by insert one character at a time. And then when we do the search, so basically we are searching character by character, and then if there's no match, we just return the original word. Otherwise, we move on to the next node, which is the child of the current node, and then we append this character, the matching character, into the result. And then if we find, okay, this node corresponds to the end of a complete word, in that case, we just stop searching, we just return, because the problem asks us to return the root that has the shortest length, return the root word in the dictionary that has the shortest length, so we can just return. Otherwise, after we search all the words, we either did not find a match or we find a match, but it's actually not the complete word. What does that mean? Let's say if the input sentence, in this example, if the input sentence contains CA, a word CA, even though it does not mean something, it does not mean anything. But let's say we add a white space CA to the end of this input sentence, and then this CA will not match any root, even though it will match the CAT for every character in this input CA, but it still is shorter than this root word. So in that case, it's not a match. So in that case, we still return the word. So that's our search function. And then in this solution, in the main function, we just initialize try, and then call the try.insert to insert every word from the dictionary into the try. And then in the end, we just call try.search, and then apply that to every word after we split these sentences by white spaces. This is how we write it in a more Pythonic way. And then for a more intuitive way, you can check the line 48 to line 51. Okay, so I want to optimize the space a little bit. So in this case, I'm going to actually write this try in a different way. So instead of representing as a tree with node, I can just represent the try as a dictionary of dictionaries. So in this case, let me delete this try node. And then for this trie, for each root, it's just an empty dictionary. And then in this case, the current is still assigned. In this case, current, the self.root is still assigned to the current. So for this line, if C not in, so in this case, it's just C not in current. Because current itself is just a dictionary. And then here, we replace current.children C with current C. Basically, we insert the key C into the current, which is a dictionary. We insert the key C, and then the value, the corresponding value, is just an empty dictionary. And then we update the current. After that, we need to indicate the end of the current. So in that case, we use a special character, pound sign. Why we are using pound sign? I mean, you can choose any different signs, just do not choose any letter from A to Z. So in this case, we can choose pound sign because this pound sign does not mean anything. And then I pick pound sign is because, okay, usually if you dial a number and then following the prompt, it will always ask you, okay, hit the pound sign in the end. So that's why here we just assign a true value. So to indicate, okay, this is the end of a word. So for search, in this case, let's replace line 27. If C not in current, we just return word. Otherwise, we update the current. So the current is the value, the corresponding value for the key C, and then we still append C to the result. And then if current, we replace this line with if this special character pound sign in this current. Okay, so this is the update. So basically, we eliminate the trie node. We're not using the trie node. We just implemented this trie. Basically, start with as a dictionary of dictionaries. So each root node is a dictionary. And then all the keys are the corresponding character for this root's children. And then for each key, the corresponding value is the children of this key. So in that case, we kind of implement the trie. So let's run the updated solution. So now you can see there is an improvement in the memory.